Okay, question 6, part A, a point of inflection. What's special about that is that d2y by dx squared equals 0. Not just dy by dx equals 0, because that could happen for a maximum point or a minimum point. What's special for a point of inflection is that the second derivative equals 0. So the first derivative, dy by dx, it's a Lund one, so the 2 stays on the top and we go k minus 3x on the bottom, multiplied by the differential of the bracket in there on the top, which is minus 3. The rest of that's quite straightforward. So you have minus 6 over k minus 3x plus 2x minus 3. If you need to differentiate this again, so if you want to write k minus 3x to the minus 1, instead, that might help you to do the differentiation, because the minus 1 will come to the front times the minus 6. It will go down by 1 times to make minus 2, and the minus 3 comes out and multiplies using the chain rule, etc. Okay, plus, and again, the bit on the end should be reasonably straightforward. So there is what the second derivative is. We need 6 times minus 3 at the front is minus 18. That minus 2 up there means that it goes underneath as a squared, plus 2 on the end, and for a point of inflection equals 0. So take the 2 over, multiply up by the k minus 3x squared, and then divide by the minus 2 to make plus 9, square root it. You get 2 answers, plus 3 or minus 3. So bring the 3 over from the other side. Yep. And you have an answer of 3 plus 3 or 3 minus 3. We've got to take the plus answer where k is 6, as in the question it says that k is bigger than 0. In part B, you're using the change of sign technique. If the line does go through the x-axis, then either side of the crossing point, one will be a positive y value and one will be a negative y value. So if you put 0.5 in and you get a positive value for y, and if you put 1.5 in and you get a negative value for y, that means that the line has got to go through the axis, so there is a root there between 0.5 and 1.5. Okay, 6c, Newton-Raphson. There's the formula. All right, we should have the f of x function from the question, and we've differentiated the f of x to go underneath. Quite complicated there, and it obviously follows through a bit from the previous question. Nothing that you can't do here, though. All right, it's just going to be subbing in numbers after this, and it tells us my starting number is 1. 1 goes in there, sub it in your calculator. Remember, there's a special calculator method where you can just keep pressing the equal sign and it will generate the next value and the next value. So these eventually come out, I'm not going to do all of them, to be 1.06568 to 5 dp. Then it says show that that is correct between to 5 dp. So you need the upper and lower bounds that would round to be 5 dp. So halfway down below to the 6 dp is 75 on the end, and upper bound halfway up to this next one, 6 dp, is 85. Sub those two values in to the equation, and again you find out that one of them becomes a positive, one of them becomes a negative. So there is definitely a root change, or there's a sign change and a root between those values, which means that it's got to be the correct answer to 5 dp.